So, my dear students, I am Dr. Vivekananda, Assistant Professor, Department of Mathematics. In previous classes, about third unit integration, that is the integration of complex functions and power series, I have explained integrations of complex functions using line integral and using curves, and also using Cauchy's integral theorem, and also using Cauchy's generalized integral theorem. Okay, and power series I explained Taylor series expansion in the previous videos. In the continuation of those videos, now I am going to give lecture on Laurent series expansion. Okay, Laurent series expansion. See Laurent's theorem statement. If f of z is analytic, if f of z is analytic, throughout annular region between the concentric circles C1, C2 are centroid at z equals to a of radii r1 and r2, where r2 is a smaller radius than r1 respectively, and z as is any point on C1, C2, then there exists a unique series expansion in terms of positive and negative terms of z minus Ca, that is f of z equals to summation n is equal to 0 to infinite an into z minus a whole power n plus summation n is equal to 1 to infinite bn by z minus a whole power n, where an equals to 1 by 2 pi I integration over C1 integration f dash of f of z dash by z dash minus a whole power n plus 1 dz dash, and bn equals to 1 by 2 pi I into integration over C2 f of z dash by z dash minus a whole power minus n plus 1 dz dash. Means here expansion of f of z over the annular region. Annular region is nothing but there are two circles, two concentric circles. So this is a smaller circle about radius r2. Okay, another circle which is also this is the center at A, which is a radius of r1. Means we have to find the expansion of f of z in the annulus region. Annulus region means the region between the two concentric circles. The region between the expansion between the two concentric circles. So that is what Laurent series. Laurent series is nothing but the series expansion in the region between the two curves, two concentric circles. Okay, so that is what Laurent series expansion, in which an and bn are constants, where those two are evaluated using these formulas, right? Now let us try to find Laurent series expansion for z f of z 1 by 1 minus z by z minus 2 in the region 1 less than mod z less than 2, and second question is in the region mod z greater than 2. Now first, so f of z, try to split into partial fractions so that you can easily find the Laurent series expansion. When I apply Laurent series expansion, when I apply partial fractions, this becomes 1 by z minus 2 minus 1 by z minus 1. This is happened on partial fractions. Okay, This has become on partial fractions. On partial fractions. Okay, so here z minus 1 minus of z minus 2 is going to be 1. So in that way I took z minus 1, 1 by z minus 1, 1 by z minus 1 is subtracted from 1 by z minus 2. Okay, so this is what f of z. F of z is evaluated using, f of z is splitted into two fractions by applying partial fractions concept. Right, now here first question is in the region 1 less than mod z less than 2 is nothing but mod z is greater than 1 and mod z is less than 2. Mod z is greater than 1 and mod z is less than 2, that is nothing but 1 less than mod z less than 2. So from these relations you try to bring from this what do you write? 1 less than mod z is nothing but 1 less than mod z is nothing but 1 by z less than 1. 1 by mod z less than 1 we can write. Okay, next this one mod z less than 2 means mod z by 2 less than 1. Why I am writing like this now? That given region is split into two regions, like 1 less than mod z and mod z less than 2, and from that these less than one region concepts I applied. Since I have given this concept in the beginning of Taylor series theorem, where the region of convergence is less than 1, means the given series, the given function, for the given function, if we want to evaluate Laurent series expansion, that Laurent series expansion in the region 1 less than mod z less than 2 is nothing but the expansion should be right in terms of 1 by mod z and mod z by 2 in this terms you need to expand in terms of 1 by z, in terms of z by 2 you need to expand. So therefore now f of z I am writing as, now I am taking f of z 1 by so z by 2 na, so here I am taking minus 2, I am taking 1 minus z by 2. See, this is z minus 2 na, so I want to bring z from z minus 2, z by 2 terms I need to bring. So for that I am taking minus 2 common, minus 1 by z minus 1 I am writing as 1 by z minus 1 I am writing as, if I bring z common, 1 minus 1 by z. Since I need to write expansion of f of z in terms of 1 by z and in terms of z by 2, in that way I wrote the given function in terms of z by 2 and in terms of 1 by z. Okay, so now f of z equals to 1 by minus 2 into minus 2 into 1 minus z by 2 minus 1 by z into 1 minus 1 by z. Okay, now which is equals to minus 1 by 2 into 1 minus z by 2 whole power minus 1 minus 1 by z into 1 minus z 1 minus 1 by z whole power minus 1. Now which is equals to minus 1 by 2 into 1 minus z by 2 expansion 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube plus and so on minus 1 by z into 1 plus 1 by z plus 1 by z whole square plus 1 by z whole cube plus and so on. So these expansions are a root by the formula 1 minus 1 minus x whole power minus 1 formula. 1 minus x whole power minus 1 formula is 1 plus x square plus x cube plus and so on. This formula I applied here. Okay, so these expansions root in terms of z by 2, in terms of z by 2 and in terms of 1 by z. So the region of convergence is, what is the region of convergence? Here z by 2 mod z by 2 less than 1 and 1 by mod z less than 1. That implies 1 less than mod z less than 2. Region of convergence means I evaluated Laurent series expansion in the region 1 less than mod z less than 2 is nothing but in terms of z by 2 and in terms of 1 by z terms. Okay. Once again, the given function is split into two fractions by applying partial fractions, and I'm trying to expand them in terms of z by 2 and 1 by z, since the provided region is 1 less than mod z less than 2. With respect to provided region, the terms should be existed in 1 by mod z and z by 2. So in such a way, I wrote the given function in terms of 1 z by 2 and 1 minus z by 2, 1 by z, and expanded accordingly. Okay, this is the way of finding Laurent series expansion. Next, second one is mod z greater than 2. Second question, mod z greater than 2. Mod z greater than 2. Second question is mod z greater than 2. Mod z greater than 2 is nothing but you should take 2 by mod z less than 1. Something should be less than 1 in such a way you need to write the terms, because the region of convergence should be less than 1. Should be less than 1, like that you create and try to evaluate and try to write those expansion. So mod z greater than 2 is nothing but 2 by mod z less than 1 in the nature of the series. In nature of the series, I wrote like this. So here I mean to take it, the f of z in terms of 2 by z. So now here f of z actually what we have, 1 by z minus 2 minus 1 by z minus 1. 1 by z minus 2 minus 1 by z minus 1. Right. One minus z. I took z minus 1. I took z minus 1 instead of. So better you change the question z minus 1 and proceed. Because I have explained this. I explained this by taking z minus 1 instead of z by 1 minus z. So please correct the question. Please correct the question accordingly. You proceed, please. Okay. Even in 1 minus z also no issue. We can do accordingly. But by mistakenly I have taken z minus 1 instead of 1 minus z. So you please change the question and proceed the solution. Now here 1 by z minus 2 minus 1 by z minus 1. 1 by z minus 2 minus 1 by z minus 1. So I need to take here. I need to take here in terms of 2 by z, in terms of 2 by z. So I am writing this as 1 by 2 by z. If I bring 2 common, 1 minus 2 by z minus, so z greater than 2. Z greater than 2 means minus if I take 1 by z minus 1, if you write as it is, if you write z minus 1, you write z minus 1 as it is. Don't go for any expansion. Okay. 1 by z minus 1. So this implies 1 by z into 1 minus 2 by z minus 1 by z minus 1. So which is equals to f of z equals to 1 by z into 1 by z into 1 minus 2 by z minus 1 by z minus 1, which is equals to 1 by z into here minus 1 will have to come here. Minus 1 whole 1 minus 2 by z whole power minus 1 have to come, because here 1 by z into 1 minus 2 by z na. So 1 by z into 1 minus 2 by z comes to numerator, means power minus 1. Okay. So this here I am expanding it. 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube plus and so on minus 1 by z minus 1. So 1 by z into 1 plus 2 by z plus 2 by 4 by z square plus 8 by z cube plus and so on minus 1 by z minus 1, which is here mod z is here 2 by z is less than 1. 2 by mod z is less than 1 and z not equals to 1 and z not equals to 1. So this is the region of convergence for the region of convergence. Okay, this is the Lorentz expansion in case of f of z equals to 1 by z minus 1 into z minus 2. 1 by z minus 1 into z minus 2. Okay. Even 1 minus z also you can do, no issue at all. Even if it is 1 minus z, you can proceed as per the as per the procedure you proceed, definitely you will get it. Instead of 1 minus z, I took z minus 1. So like this I evaluated. Next question is, find the Laurent series expansion of f of z equals to 1 by z plus 2 into z plus 1 whole square. F of z equals to 1 by z plus 2 into z plus 1 whole square. Again you need to apply partial fractions here. A by z plus 2, b by z plus 1 plus c by z plus 1 whole square. Here as the terms are the denominator, as the terms are with the higher degree terms, so I need to evaluate fractions, separate fractions by using partial fractions. I cannot write directly, so I am applying partial fractions concept and I am trying to evaluate that. So from this, what do you write? A into z plus 1 whole square, as the denominator is z plus 2 for the a, so whose corresponding component corresponding coefficient will be z plus 1 whole square on with respect to LCM, plus b into z plus 2 into z plus 1, b into z plus 2 into z plus 1, plus c into z plus 2 is equals to 1. Okay, so by taking the numerator functions on either side, we will get like this. Now put z equals to minus 1. Put z equals to minus 1. What happened? If I put z equals to minus 1, this a becomes 0, b becomes 0, only c will be left. C is equal to 1 you will get. Okay. Put z equals to minus 2. Put z equals to minus 2. If I put z equals to minus 2, then a into 1 is equals to 1. Okay, so from this a equals to 1 we'll get. A is equal to 1, c is equal to 1 we got, but you required b. So to get b, I am taking z square coefficients. Z square coefficients I am taking. Why I am taking z square coefficients? Because the b will include in z square coefficient. A and b include z square coefficient where a is known. Therefore, you can easily find out b. Z square coefficients on either sides. Taking z square coefficients on either sides, that is a plus b is equal to 0. From this b equals to minus a. From this b equals to minus a. From this b equals to minus a means minus 1. So therefore the given function f of z equals to 1 by z plus 2 minus 1 by z plus 1 plus 1 by z plus 1 whole square. This is the partial fraction we got for the given function, right? Now first question is mod z greater than 2, mod z less than 2. First question. So we have to evaluate Laurent series for mod z less than 2. Mod z less than 2 means we need to write, that is less than 1, mod z by 2 less than 1. In terms of z by 2 less than 1 we need to write. So f of z, the given function f of z equals to 1 by z plus 2, 1 by z plus 2 minus 1 by z plus 1 plus 1 by z plus 1 whole square. Now we have to reduce in terms of z by 2 na. So for that, so here 1 by 2 into 1 plus z by 2 minus here z by 2 less than 1 means mod z less than 2. Okay, so here we write as 1 plus z whole power minus 1 plus 1 plus z whole power minus 2, which is equals to 1 by 2 into 1 plus z by 2 whole power minus 1 minus of 1 plus z whole power minus 1 means 1 minus z plus z square minus z cube plus and so on plus 1 minus 2z plus 3z square minus 4z cube plus and so on. Okay, so which is equals to 1 by 2 into 1 plus z by 2 whole power minus 1 means 1 minus z by 2 plus z by 2 whole square minus z by 2 whole cube plus and so on minus 1 minus z plus z square minus z cube whole plus and so on plus 1 minus 2z plus 3z square minus 4z cube plus and so on. So here z by 2 mod z by 2 is less than 1, here mod z less than 1, here mod z less than 1. Okay, of all these the region of convergence is less than 2. The region of convergence is less than 2. The common region of the convergence is less than 2. We can write like that. Okay, so therefore the Lorentz expansion of f of z from this, the region of convergence is mod z less than 2. Mod z less than 2 means even mod z less than 1 also included in that. So mod z less than 2 is the common existence region, convergence region for the given function. For the given function, it's a Lorentz expansion. Okay. Next, for the second question, 1 plus z greater than 1. Second question, modulus of 1 plus z greater than 1 means 1 by modulus of 1 plus z less than 1. 1 by modulus of 1 plus z less than 1 means we need to write the given expansion in terms of 1 plus z. So as we know, f of z equals to 1 by z plus 2 minus 1 by z plus 1 plus 1 by z plus 1 whole square. Okay, 1 by z plus 2, here what I write now, 1 by 1 plus z plus 1 minus 1 by z plus 1 plus 1 by z plus 1 whole square. So this is what. Here I am bringing 1 by z plus 1 as taking as common. Z plus 1 I am taking as common. So then it becomes 1 plus 1 by z plus 1 will get minus 1 by z plus 1 plus 1 by z plus 1 whole square. So which is equals to 1 by z plus 1 into 1 plus 1 by z plus 1 whole power minus 1 minus 1 by z plus 1 plus 1 by z plus 1 whole square. Right. So then if you go for expand it, which is equals to 1 by z plus 1 into its expansion 1 plus 1 by z plus 1 whole power minus 1 expansion 1 minus 1 by z plus 1 plus 1 by z plus 1 whole square minus 1 by z plus 1 whole cube plus and so on minus 1 by z plus 1 plus 1 by z plus 1 whole square. On multiplication and simplification, this minus 1 by z plus 1 and this and plus 1 by z plus 1 whole square and this will get cancelled. So it gives us 1 by z plus 1 whole cube minus 1 by z plus 1 whole power 4 plus and so on will come. This is Laurent series expansion of f of z where 1 by z plus 1 is going to be less than 1. It implies the region of convergence is 1 by modulus of z plus 1 less than 1, that is 1 less than modulus of z plus 1. Okay, this is the region of convergence. This is the Laurent series expansion for the function, for the given function f of z equals to 1 by z plus 2 into z plus 1 whole square. Okay. This is what Laurent series expansion is very important. Get prepared well, right? So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.